One. And welcome back to the Screencast, boys and girls. This is Screencast number one on section 6.6, homeostasis. This is just an introduction with definitions here. All right, so let's get into it. And by the way, homeostasis is the endocrine system according to IB. Say hi to the cat. All right, so homeostasis, boys and girls, is the tendency for an organism to or cell to maintain a constant internal environment within narrow limits. So as you can see with the graph on the right, you don't want to keep something at static condition. You want things fluctuating somewhat, but you don't want it getting too much out or too low or too high. That is a disease. And how does it happen? All right. So when your body senses something is unbalanced, a specialized receptor detects an internal change and a response is generated to correct that change. Okay, so most responses here then travel to the brain, okay, which will send a message to release a hormone, which is going to respond to the change, which is then going to put things back in homeostatic balance here. All right, you have my definition there going on, same sort of deal. You can come back at that. And yeah, so it involves the nervous and the endocrine system. I'll just get the other notes up that I just described there. Nervous system, generally the brain in the form of the hypothalamus. We'll talk about that a little bit later on. And the endocrine system of various glands. All right, receptors monitor, brain regulates, brain tells an effector what to do. Effector gland releases a hormone, hormone corrects an imbalance. That's all there is to it as far as homeostasis is concerned. All right, now what is IB asking us to look at? IB is asking us to look at 5 different areas, as you can see on the bottom, one of which we already did. So it's not the entire endocrine system. So body temperature, blood glucose, which I've been referencing all year. Of course, IB always throws in a couple that are obscure, and there they are. Leptin and clinical obesity and melatonin and sleep patterns, which hopefully for you guys are improving since you're not here. And carbon dioxide level, which we did. So if I just take a look at carbon dioxide level again, as carbon dioxide level increases in your body, right? A message is sent to the brain to exhale. All right, could also speed up breathing rate and heart rate if you have to get rid of a lot of carbon dioxide. So that is what's sent to the brain. So CO2 level is not really hormonally involved. All right, so we talk then about how it's done. And that is done basically in your body with a negative feedback loop. But the female reproductive system coming up will also reference a positive loop. And again, homeostatic processes are controlled by these loops. So for instance, a positive loop is easy to understand. All right, so A, which could be a reaction to the body, could be another hormone, stimulates the release of hormone B. That stimulates more of hormone A. So if it's hormone A is secreted, and in response to higher levels of hormone A, hormone B is secreted, and the job of hormone B is to stem the secretion of more hormone A. That's a positive. So that which we want to happen gives you more of that. However, homeostatic processes are more controlled by negative loops. So these are more common in your body. And that is A stimulates or the release of hormone B that decreases the level A. So it's the reverse of what happened. So a change is detected and functions to reduce the change. And the old one that we teach when you're a freshman is a thermostat. You know, you set a thermostat at 68 degrees, it gets to 68 degrees and it turns the heat off. So that which we wanted to happen, heat to 68, actually acts in the end to reverse that. So change detected by a receptor and an effector to have the opposite effect. Negative loop, feedback loop, opposite effect, positive feedback loop, same effect. Moving on. All right, the endocrine system. The endocrine system, just a couple things that you need to remember about the endocrine system. It is ductless, okay? Not unlike the digestive system, which has the bile duct or the pancreatic duct. All secreting cells, which is any endocrine gland in your body, hormones must travel in the blood to the target cell. And that target cell could be the testes, the ovaries, the uterus, so